Hey there. Ever pop the hood of your car and just wonder what's actually going on in there? Today, we are pulling back the curtain on that incredible machine, the internal combustion engine. Let's dive right in.
It's kind of wild when you think about it, right? You pour this liquid into a tank, and suddenly this huge 2-ton piece of metal starts moving. So the big question we're tackling today is exactly that. How does gasoline make a car go? The answer is just a beautiful piece of engineering.
Okay, so at its most basic level, this is what an engine does. Its entire job is to take one kind of energy, the chemical energy locked inside fuel, and turn it into another kind, mechanical energy. Motion. And it does this with a series of really fast, really powerful, but controlled explosions. That's the combustion part. And the internal part? That just means it all happens safely sealed up inside the engine. To really get a handle on this, we're going to follow that energy on its journey, step by step. It's a pretty amazing transformation from a splash of gasoline into the actual force that pushes you down the road. This is basically the engine's entire game plan. It's a 5-step process. We start with the chemical energy in the fuel. That gets converted into thermal energy. Yep, just plain old heat from the explosion. That heat creates pressure, which makes a piston move up and down. That's linear motion. Then, that up and down motion gets turned into rotational motion, something that spins. And finally, that spinning is what creates kinetic energy, your car actually moving. So who are these stars of this show? Let's meet the key players inside the engine that make all this mechanical magic happen.
Okay, here's our cast of characters. You've got the cylinder, which is basically the stage where the explosion happens. The piston is our star performer. It's the part that gets shoved by the force of that explosion. The spark plug is the director calling action. It provides the little spark that starts everything. The valves are like the bouncers at a club, letting the fuel and air in and the exhaust out. And the crankshaft, it's the real genius here, turning all that up and down drama into a smooth, spinning motion. Now, these parts don't just do their own thing. They work together in this incredibly precise, repeating rhythm. It's called the 4-stroke cycle, and it is, for all intents and purposes, the constant heartbeat that keeps your car alive. It all kicks off with the intake stroke. The piston moves down inside the cylinder, creating a vacuum that whoosh sucks in a perfect mixture of air and gasoline. It's like the engine is taking a big, deep breath before the action starts. Next up, compression. The piston reverses direction and moves back up, squeezing that air and fuel mixture into a teeny tiny space. Now, why do that? Well, because when you compress that mixture, the explosion you get is way, way more powerful. You're building up all that potential energy. And this is the moment we've been waiting for, the power stroke. At that exact instant of maximum compression, bam, the spark plug fires, igniting the mixture. It creates a massive, powerful explosion that slams the piston back down with incredible force. This single stroke is what actually powers your car. Okay, finally, you gotta clean up the mess. That's the exhaust stroke. The piston moves up one last time, and as it does, it shoves all those used, burnt gases out of the cylinder through the exhaust valve. This clears the way so the whole cycle can start right over again. So that's the whole dance. Intake, compression, power, exhaust. A really easy way to remember it is suck, squeeze, bang, blow. And here's the crazy part. This isn't happening in slow motion. In your engine, this 4-step cycle is repeating itself hundreds, sometimes thousands of times every single minute. But wait a minute, we've got a piston that just moves up and down. That's great, but car wheels need to go round and round. So how in the world do you get from one to the other? This is where the real mechanical brilliance shines through. So here's the solution, and it's so clever. The piston's up and down linear motion is connected to the crankshaft. And the crankshaft is designed in such a way that it perfectly translates that linear push into a rotational spin. Honestly, the best way to picture it is to think about your leg on a bicycle pedal. Your knee goes up and down, but it makes the crank spin in a perfect circle. Same exact principle. Now, I've been using the word explosion a whole lot, which might make you wonder, hey, if there are thousands of tiny explosions going on inside this metal box, why doesn't it just, blow apart? It all comes down to control. First, those explosions are happening inside incredibly tough steel or aluminum cylinders built to take the pressure. Second, the timing is absolutely perfect, controlled down to the microsecond by your car's computer. The pressure is released in these very short, manageable bursts, not one big chaotic boom.
And on top of all that, a cooling system is constantly working to pull all that extra heat away. So it's much less like a bomb and more like a perfectly timed series of very powerful pushes. So when you put it all together, what you get is this beautiful, continuous loop. Air and fuel go in, they get compressed, they're ignited to create motion, and the waste gets pushed out. And then it happens again and again and again, thousands of times a minute, smoothly turning a liquid fuel into the motion that carries you wherever you want to go. You know, for over 100 years, this incredible symphony of controlled explosions has defined how we get around. It's truly a marvel of engineering. But as we stand here today, it leaves us with a pretty big question. If this engine was the machine that defined the last century, what's going to be the one that defines the next?